In this video, we will look at the following problem. We have a platform, that's this rectangle here, that is placed on two supports. Here's support 1, here's support 2. How far can a person, this guy right here, walk past the end of that support before the platform tips over? We are given the mass of the platform, the mass of the person, and the dimensions of where the supports are placed on the platform. What we are asked for is how far this person can walk, which I'll label RH in this diagram, until the platform tips over.
In this type of problem, the idea that we're going to use is static equilibrium. When solving static equilibrium problems, we have three equations that we can look at. We have that the sum of all forces in the x direction must equal 0. The sum of all forces in the y direction must equal 0. And the sum of all torques must equal 0. Similar to a Newton's second law problem, since we are dealing Similar to a Newton's second law problem, the static equilibrium problem involves summing all the forces. In order to do that, we should start out with a free body diagram. So I'm going to start with a free body diagram for the platform. The forces that I can identify, I'm going to label these A and B. I'm going to have an upward force from the support of A. I'm going to have an upward force from the support of B. There will be a downward force due to the weight of the platform. I'm going to call that F sub P. And there's going to be a downward force due to the weight of the person, which I'll call F sub H, H for human. As I try to write out the components, I see that there's no x components, and so I can ignore that equation. Looking at the y components, then I will write out positive FA plus FB minus FP minus FH is equal to 0. Now I'm going to use the formula for gravity to replace Fp and Fh with their masses. This gives me Fa plus Fb minus the mass of the platform times gravity minus the mass of the human times gravity is equal to 0. This is one of those equations that I will use to solve the problem.
Next, I need to look at the sum of all torques in the problem. So I need to find the torque due to each one of these forces. This requires some careful thought. First, I have to identify what will be the center of rotation. In this problem, since we're asking about tipping, it will tip around the second support. So I'm going to put the center of rotation at the location of that second support. I now need to write out the torque due to each of the forces involved. I will start out by drawing a torque diagram. I'm going to mark the center of rotation for our system with a red dot. I now need to draw the displacement vectors and the forces for each one of the forces involved. First, we have going from left to right. I now need to draw each of the displacement vectors and forces for every force involved. Going from right to left, I have the displacement vector for the person and the force due to the weight of the person. Next, I would have the force due to support B, but since the displacement vector for that force is 0, I can ignore that force. Next, I need to worry about the torque due to the weight of the platform itself. Now, the gravity acts on the platform at the center of mass. This is a 10-meter long platform, so 5 meters from the end, or 1 meter past platform B, is going to be our displacement vector for the platform, and I will draw in the force due to the weight of the platform. Finally, I'm going to have the force due to the support at platform A. That points in the upward direction. And I have the displacement from the center of rotation to that support A. I noticed that for each one of these forces, they act at right angles to the displacement vectors, and so for each one, I'm going to say that the angle is 90 degrees, and sine of 90 is equal to 1. I'm now going to write out the forces the torques for each one of these forces using the formula torque is equal to R F sine theta, where sine theta is going to be 1 in this case. I will start out again going from right to left with the torque due to the person. So RH times FH. And this is going to tend to twist the system in a clockwise direction. So I'm going to make that negative. Then plus RP, FP, where I chose plus because it will tend to twist it in the counterclockwise direction. And finally, minus RA, FA, all equal to 0. Finally, I'll replace the the weights for the person, FH, and the platform, FP, with the formulas of force due to gravity. So this is now minus RH mh times g plus RP mp times g minus RA FA, all equal to 0. This is the second equation that I can use to try and solve this problem. Now let's take a short pause as a reminder. The problem is asking for this distance, RH, that the person can walk past the end of the platform before the platform starts to tip. With the two equations that I've written out, I have 3 unknowns. I have FA, FB, and RH. With 3 unknowns and 2 equations, this problem might seem difficult at this point. However, it's going to help us to think critically what's going to happen to this force F sub A as this system starts to tip. As the person walks further and further out, F sub A is going to get smaller and smaller until it finally goes to 0. At the point where F sub A goes to 0, this system will start to rotate. And so essentially what we were asked is to find RH when F sub A goes to 0, which is going to make our system easier to solve. In fact, at this point we can see we only need this lower equation, which only has RH and no FB in it, to solve for RH. Moving RH to the other side and dividing both sides by mh times g gives us RP mp divided by mh. Plugging in numerical values, we get 1 meter times 30 kilograms divided by 75 kilograms. Quick look at the units. We'll say that we have kilograms cancel on top and bottom, leaving us with meters, which tells us we're on the right track because we at least have the right units. Evaluating 30 divided by 75 gives us a solution of 0.4 meters, or RH is equal to 40 centimeters. Interpreting that, we would say that the person can walk 40 centimeters before the platform will tip.